Welcome to Study Loop.
Hello everyone, here it is given a spacecraft and satellite are diametrically opposite positions in the same circular orbit of altitude 500 km. As it passes through the point A, the spacecraft fires its engine for short interval of time to decrease its speed and enter the elliptical orbit. Knowing that the spacecraft returns to A at the same time, the satellite reaches to A after completing 1.5 orbit. We have to calculate increase in speed required, periodic time for the orbiting orbit. So we have to calculate first part, increase in speed required, delta V required, and B, the periodic time for elliptic orbit T. Let us start solving. As you know, for Earth, radius is given 6.37 into 10 to the power 6 meter. Acceleration due to gravity on the Earth's surface 9.81 meter per second square. So value of capital G into M is equal to gr square, that is 9.81 into so this value you will get 398.06 10 to the power 12 meter cube per second square. For circular orbit of satellite, radius of the orbit is r plus h, and r is the radius of the Earth 6370 plus altitude, that is 500 kilometers. So it will be 6870 kilometers or 6.870 into 10 to the power 6 meter. And orbital speed is given by, for circular orbit, gm. You can write for circular orbit of satellite. Calculate the value. gm 398.06 10 to the power 12, and r naught is 6.870 10 to the power 6. So orbital velocity of the satellite you will get 7.6119, and time period of revolution will be 2 pi r naught upon v naught. R naught, as you know, 6.87 10 to the power 6. Orbital speed we have measured 7.6619 10 to the power 3. So time period of revolution will be 5.6708 into 10 to the power 3 seconds. For elliptic orbit of spacecraft is given 3/2 tau naught, that is So time period of elliptical orbit of spacecraft is 8.5062 10 to the power 3 seconds. So semi-major axis is half of Ra plus Rv, and semi-minor axis is root of Ra into Rv. We know that Ra can be defined as Gm upon h square c cos of theta a, and Rv is defined as Gm upon h square c cos of theta b. Since both are diametrically opposite, so you can say theta b is theta a plus 180. So 1 upon Ra will be Gm upon h square c cos of theta a, and 1 upon Rb will be c cos of theta a. Adding both, you will get 1 upon Ra plus 2Gm upon h square. It can be written as 2Gm upon h square can be written as Ra plus Rb over Ra into Rb. So we can write in terms of major and minor axis, that is 2Gm upon h square a upon 2a upon b square. So from here h you will get root of Gm b square by a, and periodic time is defined as 2 pi ab upon h, and h we know, substitute the value. So 2 pi ab upon root of this 2 pi ab upon this value. So you may write a upon root of Gm into v square. So we will get time period to be 2 pi ab root of a upon root of Gm into v square, and it can be written as 2 pi a to the power 3 by 2 upon root of Gm. So a cube you will get Gm t square upon 4 pi square. Substitute the value. G into m is 398.06 into 10 to the power 12. Time period already we have calculated. into 3.14 square. So a cube you will get 729.558. Taking the cube root, you will get a is equal to Ra is equal to R naught. So Rv is equal to 2a minus Ra. So Rv we will get 11.1346. So value of P you will get substituting the value of Ra and Rv. So saving minor axis you will get 8.7461. Angular momentum per unit mass is 2 pi Av upon tau. Substituting the value, A is measured 9.0023 into 10 to the power 6. B is 8.7461 and time period is 8.50. So H will be per second. Velocity at A will be H upon Ra, and Ra is given increase in speed at A. Substitute the value. So this is the answer of A part. Periodic time of elliptic orbit already we have calculated. Eight point 5062 into 10 to the power 3 seconds. That's all for it.